For SIAF2020, we were going to be showing Archaeabot, a post-climate change, post-singularity life form. It's an underwater robot artwork that we developed as part of an EMAP residency at Laboral in Spain. Archaeabot is one of a series of robotic projects that we've done together that explore our evolving relationship to technology, science, and the world around us.
When you come into the gallery and see the Archaeabot, what you see is a tank filled with water in a darkened space, and inside that is a glowing, almost spherical robot spinning its tails and sensing its environment and shifting pebbles around in the bottom of the tank and trying to sometimes reach out of the tank with its tails. And these tails are being moved around and controlled by the neural network and controlled by sensors inside the robot. And the robot has this kind of turquoise glow to it when you see it, and it seems quite ethereal in a kind of darkened space.
Archaeabot has a machine learning system built in. It reads sensors including the speed of the motors, the direction that they're turning, also the accelerometer inside measures the movement, which direction it's facing and how fast it's moving in that direction, as well as the temperature of the water. Over the many exhibitions that Archaeabot has been included in, it has collected the data and used it to evolve its own neural network that controls the direction and speed that the motors turn. It's not necessarily evolving a neural network that humans could understand. It's evolving its own survival techniques for a post-human world.
I worked with Amanda Wilson, who's sadly passed on since we made the project. And we worked in the laboratory at Imperial College in London. She was a cryomicroscopist as well as a sound artist, and she was able to visualize these archaea by freezing them in 3 dimensions and then looking at them under a very high resolution scanning electron microscope. And so we could see the sort of undulating shapes of them, but more than that, we were looking for the particular these arcellar motors that they have on the surface of them. So you have they're almost like cogwheels, like tiny cogwheels inside of each other, which is so bizarre when you look at that kind of level to see them. And they're powered by ATP to kind of spin the tails of the archaea around, and this helps it kind of tumble around in its environment and hopefully end up in a better situation. So they're incredibly simple life forms. They're simpler than bacteria. They're simpler than these E. coli bacteria that are famous for having the tails and being able to swim about, because they have the ability to kind of almost seek out better situations and move towards them. But the archaea don't. When they're in an environment and they're happy, they don't have tails on their surface. But if they're unhappy, the tails kind of pop out from the cells, and they are able to kind of swim and move around in an environment. And at the when they find a better situation, if they find a better situation, those tails then drop off again. So the scientists that we were working with Amanda, they're studying, it was part of the MARA project at the BB lab, and they've been studying how you could learn how to build these motors that the archaea use in order to repurpose them, basically to build them out of a technique using called DNA origami, where you can actually sculpt physically with DNA. And power them in the same way as they would be powered in the cell, but actually maybe be able to use them as kind of nanobots that might have the ability to, instead of having tails, have kind of drill bits that could kind of drill into bad cells in the human body and maybe destroy bacteria, destroy cancer cells and things like that. So it was a really interesting experience in the lab to work with this liquid nitrogen and fast freeze these things, and you've got all this kind of amazing kind of hissing frozen, bubbling things as you're freezing the archaea. So it's a very interesting kind of experience, and the research there was kind of fascinating. And I was thinking about the way that they were talking about robots, and they could make kind of nano robots using this research, and that's what led to the idea of creating the archaea bot as a robotic form, and then fusing it with this idea of the kind of the post-singularity fear, this idea that we're also frightened of robots, and well, not all of us, some of us love robots, but that many of us are so frightened of robots and AI and what implications this might have for the world, for nature, for the environment, for the world we live in. I think the idea of roots and clouds is fascinating because we're all linked by them, and the archaea that we based the piece on, they're extremophile archaea, and so they tend to live in places like hot springs. But other archaea, they've been found in every environment, even inside the human body. They don't cause disease as far as we know, but they're kind of have been found in all sorts of locations. And because they have this extremophile ability, that like the birds and the geese that we can hear around us, they might have the ability to kind of travel around the planet. It might be that the archaea are also traveling around the planet in the clouds with the rain and things like that. So maybe that they're seeding the clouds, and they're causing the rain in order to be spread. There's some thoughts that bacteria and archaea might be doing this in the clouds. And in terms of the roots idea, I mean, archaea are kind of part of the root of us, of humanity. We actually, on the tree of life, they're one of the three branches, with bacteria, archaea, and the eukaryotes, which are us, and plants, and insects, and fish, and birds, and everything that has a cell with a nucleus in it is on a separate branch of the tree of life. The archaea are separate to that. They look just like bacteria, but actually they use the DNA replication systems that we use. So it's thought that we actually have branched off from the archaea, and at an earlier stage of our evolution we come from archaea. So they're our roots. So the piece actually is very deeply connected to both the roots and the clouds, if you think about it. When we first heard that we were going to be exhibiting in Sapporo at SIAF, we were very excited and honoured, and we're very sad not to be able to travel there. We've exhibited archaea bot around the world, places like Ars Electronica Festival in Austria, and in Chengdu at the Z-Art Museum in China, but we've never taken the work to Japan. It's even been to Bengaluru in India, and lots of different places, but never in Japan. And we've actually never travelled to Japan either, so we would have been very excited to see the amazing environment there, which is very different to the English countryside that you can see behind me. The context of the pandemic is very interesting, particularly in work related to microbiology, which is a big focus of my own interests, and things like antibiotic resistance and big issues that are affecting humanity at the moment.
We've both been affected by the pandemic in our artistic practice. The main issue being that we've both had many exhibitions cancelled during this period and reaching into the next year. We've spent the first 6 months of lockdown thinking how digital art can be exhibited when there are no physical locations to show it in. The most obvious answer is obviously to distribute it over the internet. As of earlier this year there were over 4.5 billion people with internet access in the world. So this seems like a really amazing opportunity to connect with those audiences. If we look at the music industry, where music has effectively been devalued due to its recording and mass duplication and ease of transmission of the recorded form, has fundamentally devalued the ownership of music to the point where it's almost difficult. It's difficult enough to just make a living out of being a musician. Digital art has the same risks. If you distribute the artifact that you're creating in its native digital form, you lose all control over that artifact. You not only lose control of the ability to charge money for it, but you also lose the context in which people will experience that artwork. If you do a video work, for instance, and you put it out on social media or a content sharing site, you don't know whether somebody's going to be viewing that on a small mobile phone screen, a large TV, or what situation they might be seeing it in. While it's a wonderful idea to democratize the access to artwork through digital means, we run the potential risk of losing the impact of these artworks if they're not presented in a considerate and sympathetic way. That's where we can see that galleries fulfill an absolutely vital role of creating spaces where art can be seen in the environment and the presentation that does it the most justice. When you look through a feed of images on a system like Instagram, I'm struck by how much time and effort must have gone into many of these pictures, but it's all too simple to scroll past and not really take time to experience or understand those artworks. I feel it's vitally important that we enable art to be experienced in the proper context. It doesn't do the artist any favours to not provide that facility, and fundamentally it doesn't value the audience, and in fact it cheats them out of that experience that they might have. And that's why we're very sad not to be taking part in the physical exhibition of SIAF. We very much enjoy showing Archaeobot, and we wish we could have been there to show it to you and talk to you about it.